Part 1. Digits, numbers, and place value. Before we work with large numbers, let's begin with something simple. What is a digit? A digit is a single symbol used to write numbers. In our number system, we have 10 digits: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Every number you have ever worked with, small or large, is made from these 10 digits. What is a number? A number tells us how many or how much. A number can have one digit, like 7, two digits, like 42, three digits, like 639, or many digits, like 1,245,900. Numbers grow larger as we add more digits, but the digits only have meaning when we know its place. What is a place value? Place value means that a digit's value depends on its position in the number. For example, the digit 6 can mean 6 ones, 6 tens, which gives us the number 60, 6 hundreds, making number 600, 6 thousands, which is 6,000, and so on. The same digit can have different values depending on where it appears. Part 2. Partitioning whole numbers. Let's take the number 482. We can break it into place values. The 2 is in the ones place, making just 2. The 8 is in the tens place, which gives us 80. The 4 is in the hundreds place, which is 400s. So we can partition it as 482 equals 400 plus 80 plus 2. This is called partitioning. Partitioning helps us see how each digit contributes to the overall value of the number. Let's see another example. Let's examine the number 300,594. When we partition a number, we begin on the right-hand side, because the rightmost digit always represents the ones place, and each position to the left has a value 10 times greater than the place before it. Now, let's break the number into its place values. The 4 is in the ones place, making 4. The 9 is in the tens place, making 90. The 5 is in the hundreds place, which is 500. The 3 is in the thousands place, which gives us 3,000. So we can partition it as 3,594 equals 3,000 plus 500 plus 90 plus 4. This clearly shows how each digit contributes to the total value of the number. Part 3. Place value chart. To help us understand partitioning, we use something called a place value chart. The place value chart has columns from right to left, like ones, tens, hundreds, thousands, 10,000s, and 100,000s. Before we continue, I want to show you a quick and efficient way to set up place value chart when we work with numbers, especially large numbers. It takes time to write out the full words, ones, tens, hundreds, thousands, and so on. To make this easier, it is better to use abbreviations. These are simply the first letter, or the first two letters, of each place value name. Here are the abbreviations we use. O for ones, T for tens, H for hundreds, TH for thousands, TT for 10,000s, HT for 100,000s. Using these letters makes it much faster to set up a place value chart, especially during practice or in a time-sat arithmetic test. Let me show you how it works. Look at the number 325,436. The 6 is in the ones place. That means it is just 6 ones. Digit 3 is in the tens place. This represents 3 tenths or 30. The digit 4 is in the hundreds place, so it represents 4 hundreds or 400. The digit 5 is in the thousands place, so that means 5 thousands or 5,000. The digit 2 is in the 10,000s place, so it means 2 10,000s or 20,000. The digit 3 is in the 100,000s place, so that means 300,000s or 300,000. When we add these values together, 300,000 plus 20,000 plus 5,000 plus 400 plus 30 plus 6. We get the number 325,436. Too hard to understand? Okay, let's continue from smaller numbers in the next example. Let's try another one. Look at the number 9,174. The 4 is in the ones place, so it means 4. The 7 is in the tens place, so it means 7 tens or 70. The 1 is in the hundreds place, so it means 100. The 9 is in the thousands, so its value is 9,000. Adding those values together, 9,000 plus 100 plus 70 plus 4 equals 9,174. So remember, the place where a digit is written in a number tells us its value. Also, we can learn about place value using multiplication. This will help us see how each digit in a number gets its value. Look at the number 725. The digit 5 is in the ones place. To find its value, we multiply 5 by 1. So 5 times 1 equals 5. That means 5 ones or just 5. The digit 2 is in the tens place. To find its value, we multiply 2 by 10. So 2 times 10 equals 20. That means 2 tens or 20. The digit 7 is in the hundreds place. To find its value, we multiply 7 by 100. So 7 times 100 equals 700. That means 7 hundreds or 700. Now, if we add these values together, 700 add 20 add 5, we get the number 725. If we use a place value chart, we have the same answer. So remember, the core idea is this: to find the digit's true value, you just multiply it by its place. Ones place, multiply by 1. Tens place, multiply by 10, and so on. If it is hard for you to multiply by 10, 100, or 1,000 right now, don't worry. We will cover multiplication in more detail later in this lesson. But for now, let's practice what we've learned by using a place value chart and partitioning the number 6,239. First, let's quickly write the place value table starting from the right-hand side, because the rightmost digit is always in the ones place. We have ones, tens, hundreds, thousands, and 10,000s. Now let's partition it. The digit 9 is in the ones place. That means 9 ones, or just 9. The digit 3 is in the tens place. That means 3 tens, or just 30. The digit 2 is in the hundreds place. That means 2 hundreds, or 200. The digit 6 is in the thousands place. That means 6 thousands, or 6,000. Notice that there is no digit in the 10,000s place. That means we have 0 10,000s. So when we partition 6,239, let's break it into 6,000 plus 200 plus 30 plus 9. This is how a number is built. Each number has a value because of the place it stands in. Now that we understand digits, numbers, and place value, we can move forward to larger numbers and explain how they behave. Let's continue to our next topic of this lesson. Part 4, Understanding a Large Number. We learned that we have 10 digits and that those digits form numbers. Most importantly, we saw that a digit's value depends on its place in the number, what we call place value. We got so good at using a place value table to break numbers apart, but what about large numbers? On the screen, you can see the number 7,320,270. Before we do anything else, let's break it into its place value components. What do you already know that could help with this problem? If your answer is place value charts, you are absolutely right. Let's write the place value charts for this number. Starting from right to left, we have ones, tens, hundreds, thousands, 10,000s, 100,000s, and we add here millions. The digit 0 is in the ones place. That means 0 ones, or simply 0. The digit 7 is in the tens place. That means 7 tenths, or 70. The digit 2 is in the hundreds place. That means 2 hundreds, or 200. The digit 0 is in the thousands place. That means 0 thousands, or 0. The digit 2 is in the 10,000s place. That means 2 10,000s, or 20,000. The digit 3 is in the 100,000s place. That means 300,000s, or 300,000. The digit 7 is in the millions place. That means 7 millions, or 7 million. So we can write 7,320,270 320,270 equals 7,000,000 plus 300,000 plus 20,000 plus 200 plus 70. Don't worry if it's tricky, that means your brain is growing. Let's try another example. Partition the number 8,401,925. Pause the video now and try it on your own. Take your time. Let's see how to partition the number 8,401,925. Now, here's a useful tip that will help you on your exam and improve your accuracy. At the exam, you will have a space to make notes and calculations, usually a grid made of squares. Use this space to write the number carefully, placing one digit in each square, digit by digit. Let me show you how to do this. The digit 5 is in the ones place. Draw a short line, just one square, and write 5. This means 5 ones or just 5. The digit 2 is in the tens place. Now draw a slightly longer line down the two squares and write the digit 2 in the next squares to the right. Write a 0. This shows 20. The digit 9 is in the hundreds place. Draw a longer line down 3 squares and write the digit 9 in the following squares. Write 2 zeros to show the zeros. This clearly shows 900. You can continue this for all the digits in the number, drawing lines down to show the place value and writing zeros as needed. Pause the video and see how far you can get on your own. Remember, any progress is excellent progress. Okay, let's finish it. The digit 1 is in the thousands place. Draw a line down 4 squares, then write 1. To the right, write 3 zeros to see 1000. The next digit is 0 in the 10,000s place. This means that there is no value in the 10,000s place. You can simply leave this space empty or write 0. The digit 4 is in the 100,000s place. Draw a line down 6 squares, then write 4. To the right, write 5 zeros to show 400,000. Finally, the digit 8 is in the millions place. Draw a line down 7 squares, then write 8. To the right, write 6 zeros to show 8 million. So when we partition 8,401,925, it becomes 8 million plus 400,000 plus 1,000 plus 900 plus 20 plus 5. Great job. That's how each digit's value depends on where it is placed in the number. Now, I'd like you to pause for a moment and consider, what would be the value of the digit 9 in this number if it were moved one place to the left? You've got it. It's now worth 9,000. It became 10 times larger. Moving left makes a digit more powerful. This leads us naturally into the next concept. Part 5. Digit shifting, multiplying by tens, hundreds, and thousands. When we multiply a number by tens, hundreds, or thousands, the digits shift to the left. When multiplying by 10, which has one zero, digits move one place left. When multiplying by 100, which has two zeros, digits move two places left. When multiplying by 1,000, which has three zeros, digits move three places left. Let's break it into by pieces. Here is the task. 125 times 10. The digits are 1 in the hundreds place, 2 in the tens place, 5 in the ones place. When we multiply by 10, each digit shifts one place to the left. The 1 from the hundreds place moves to the thousands place, becoming 1,000. The 2 from the tens place moves to the hundreds place, becoming 200. The 5 from the ones place moves to the tens place, becoming 50. Then we add 0 to the ones place, which is normally called a placeholder. After shifting all digits, the new number is 1,250. Well done. When you multiply any whole number by 10, remember, when you shift digits left, they jump one spot to the left. To fill the empty space behind, you add a placeholder, or 0, which makes the whole number bigger. Because 125 is a whole number, we can use a second method. When we multiply any whole number by 10, we can simply add one 0 or a placeholder to the end of the number. So if we add 1 0 or a placeholder to 125, we get 1,250. Let's explore the next example. 3,217 multiplied by 1,000. When we multiply a number by 1,000, every digit moves 3 places to the left on the place value chart. So 3 from the thousands place goes to the millions place. 1, 2, 3. And becomes 3 million. So the 2 from the hundreds place shifts to the 100,000s place, becoming 200,000. 1 from the tens place shifts to the 10,000s place, becoming 10,000. And 7 from the ones place goes to the thousands place, also jumping 3 places to the left. Add 3 zeros or 3 placeholders to the end of the number, the same number of zeros as in the number 1,000. So 3,217 becomes 3,217,000. The number becomes 1,000 times larger, but the digits themselves stay in the same order. We can also use a second method. Because 3,217 is a whole number, we may apply the shortcut. When multiplying a whole number by 1,000, we simply add 3 zeros to the end of the number. This gives 3,217 times 1,000 equals 3,217,000. Both methods lead to the same result. Let's try another example. What is 43 multiplied by 100? Try solving this yourself. Use the 30 seconds to find a solution. To multiply by 100, we move each digit 2 places to the left, so 43 from the tens place and the ones place move to the thousands place and the hundreds place, and becomes 4,300. Again, we may use the whole number shortcut. Because 43 is a whole number, we can simply add 2 zeros or 2 placeholders, because 100 contains 2 zeros, which shows that 43 times 100 equals 4,300. In both examples, the outcome is clear and always works the same way. When multiplying a whole number by tens, hundreds, or thousands, you simply add 1, 2, or 3 zeros or placeholders to the end of it.